Good morning, children. Welcome back. In the previous video, we have seen about the Mendeleev's periodic law, the modern periodic law, and the Doberanier's triad. Correct? So, in this video, we are going to see about the Newland's octaves law. Okay, so Newland is was a scientist who classified the elements in increasing order of their atomic masses into groups of 8 elements. Dobereiner grouped into 3 elements. He grouped into the 8 elements, okay, called octaves, like notes of music. You know the octaves. Octaves are sa, re, ga, ma, pa, da, ni. Okay, these are the octaves. So these are called the notes of music. He found that when elements were arranged in the increasing order of their atomic masses into octaves, then there was similarity of properties in every eighth element. That is, the first element and the eighth element had the same properties. There was a similarity in the first property and the eighth element property. Okay, this was the Newland's octaves law. Octaves means what? There you know the octaves, notes of the music. There are 8 notes of music. That is sa, re, ga, ma, pa, da, ni. Okay, so as per these notes of the music, the Newland, what he did, he arranged the elements into the increasing atomic masses, and then he realized, or he noticed, that he observed that the properties of hydrogen and the properties of oxygen was same, and this was the Newland's octaves law. Okay, same case was in the fluorine and the sulfur, then the chlorine and the ferrous. Okay, that is iron. Then there was cobalt and nickel and the serentium, then the bromine, and there was no eighth element only. Correct. So in other these four charts, there was the first element and eighth element, but in this last there were no eighth element remaining. So this was the defect in the Newland's octaves law. Okay, so all known elements and elements discovered later could not be correctly arranged into the octaves. Some elements having different properties were placed in the same rows, like cobalt and nickel. Yes, the cobalt and nickel, they were having different properties, but they were placed in the same tablet. Correct. So having different properties and placed along with the fluorine, chlorine and bromine, that is, they were placed in the column of sa, that is first note of music. Iron having properties similar to cobalt and nickel are placed in the different rows. Yes, the ferrous and the cobalt and nickel have same properties, but still they were placed in the different places. So these were the defects in the Newland's octaves law. So that's why this law was also not acceptable by anyone. Okay, so these were the laws which you have to remember. That is, the first one was your Mendeleev's periodic law, then the modern periodic law, then your Doberanier's triads, and then this was a Newland's octaves law. Till now we have covered 4 laws, and you have to learn by heart these laws. Do not do any your own discoveries in this law. You have to learn this law as it is. Okay, do not change any of the words. So now, on the basis of the Mendeleev's periodic law, the Mendeleevs derived the periodic table. So Mendeleev classified elements in the increasing order of their atomic masses and similarities in their properties. The formulae of oxides and hydrides formed by the elements was also basis for the classification of elements. That is, oxidation and hydrogenation reactions also were the basis of the classification. That is, which elements did go under the oxidation, which elements go under the hydrogenation. Okay, so these are the classification basis also. Then Mendeleev's periodic table has 6 horizontal rows called periods and 8 vertical rows called groups. The groups 1 to 7 had two subgroups called A subgroup and B subgroup. Group 8 had three rows of elements. Elements having similar properties were placed in the same groups. These are some spaces left vacant. There are some spaces left vacant in the table to accommodate the elements to be discovered in future. So they had kept the empty spaces also, that someone will discover the element and then they will put the element over there. So the merits of this Mendeleev's periodic table was elements were classified on the more fundamental basis of their atomic masses and properties. The whole table was dependent upon the atomic mass. Spaces were left vacant, so that there were no such thing that you discover and then I'll adjust you somewhere. No, the some spaces were kept over there so that the vacant space would be filled up after the discovery. It would predict the properties of elements which helped in the discovery of new elements. Then the inert gas elements discovered later could be placed in a separate group without disturbing the table, as there was a vacant space given over there. So all the inert group elements were placed sideways. And now, what were the defects of these periodic table? That some elements are not arranged in the increasing order of their atomic masses. That is, cobalt is placed before nickel, and the position of hydrogen is not clear because it shows properties similar to the metals as well as non-metals, and still the hydrogen is placed in the first position of the periodic table. The position of isotopes of elements is not clear. Okay, this concept is very deep. So isotopes means many of the same, they are having the same atomic masses, same atomic masses but different atomic number, or they have the different atomic number and they have same atomic masses. Okay, these are the isotopes which did not have any place in the periodic table. So that's why the modern periodic table was discovered. In modern periodic table, elements are arranged in increasing order of their atomic numbers in the form of table having 7 horizontal rows of elements called periods and 18 vertical rows of elements called groups. So what were the periods? There are 7 periods of elements as follows. That is, first period has 2 elements, hydrogen and helium, called very short period. Then there is again second is short period, third is short period, fourth is the long period, that is of 18 elements. Fifth period has 18 elements called long period. Sixth period has 32 elements called very long period. Then seventh period has 28 elements called incomplete period, and 14 elements each of the sixth and seventh periods are placed separately at the bottom of the table. That is, the 14 elements of sixth period from lanthanum are called the lanthanides, and 14 elements of the seventh period from actinide are called actinides. Okay. Then the groups, there are 18 groups divided into 9 main groups. That is, the first two 0 group elements. The groups 1 to 7 has 2 subgroups each, like A subgroup and B subgroup, and the 3 rows of elements, and the 0 group has 1 row of elements. The A subgroup elements are called normal elements and B subgroup elements are called transition elements. Okay, transition means what? Going from one phase to another phase. And lanthanide and actinides are called inner transition elements. When we see in detail, you are going to know why those are named as transition and inner transition elements. Like first 1A group elements are called alkali metals, second A group are known as alkaline earth metals, 7A group is known as halogens, and 0 group are called noble gases. These you have to remember. Okay, children. In group, all the elements have same number of valence electrons. Group 1 elements have 1 valence electron, group 2 elements have 2 valence electrons, 3 has 3 valence electrons, and so on it goes. In the period, all elements contain the same number of shells. Okay, so according to the atomic number is number of electrons. So as the number of electrons increases, the atomic number is going to increase, and on this basis the groups and the periods are done. See over here, that is a modern periodic table of elements. The hydrogen is given separately, then there is a zigzag line over here between, see this one, correct, that is the transition group. Okay, seventh is known as the seventh group is known as the halogen group, correct. So this is 9, see this is the halogen group: fluorine, chlorine, bromine, iodine. These are the halogen groups. Okay, and this is known as the helium, that is the inert gases: helium, neon, argon, krypton, xenon, radium, rantium. Okay, these are the, and this first group is known as the alkali metals, and this is known as the alkaline earth. Okay children, so this was the modern periodic table of elements. In the next video we are going to see the properties of these elements. Okay, thank you children.